Today we're going to graph exponential growth and decay functions, mostly not using a graphing calculator. If you have a graphing calculator, I'll tell you how you can use that to make this a little bit easier. If you want to borrow one of mine, you're always welcome to in class. So the equation y equals b to the x is an exponential growth or decay function. And we'll get into when it's exponential growth and when it's exponential decay later. But basically, if b is larger than 1, it's growth. If b is less than 1, like 1/2, 1/4, 1/3, then it's exponential decay. We talked yesterday about the asymptote. The asymptote is a line that the graph approaches as you move away from the origin. You may want to add that the graph never touches or crosses the asymptote. The graph of y equals a times 2 to the x has certain characteristics. If you were to plug in 0, anything raised to the 0 power is 1, and 1 times a is a. So whatever number is in front of the function, whatever number is being multiplied in front, that is going to be the y-intercept. So it will pass through the point 0a, the y-intercept is a. So whatever number is multiplied in front of the function, that will be the y-intercept on the graph. The x-axis is an asymptote. Number 3 is the easiest part of all of today, the domain. Anyone? All real numbers. And remember that we can use the capital R with a double stem to represent real numbers. The range is either going to be y is greater than the asymptote or y is less than the asymptote. Y is greater than the asymptote when the graph is above the asymptote. Y is less than the asymptote when the graph is below the asymptote. And we'll see an example of both today. To graph y equals a times b to the x minus h plus k, we are basically going to just look at everything up to the x and then stop. So we're going to sketch the graph of y equals ab to the x. Then we will use the minus h and the plus k to move those temporary points to their actual locations. So in our little table of values, we are going to put in temporary points and then move those points left, right, up, or down based on the equation. So this first example, y equals 3 times 2 raised to the x plus 1 minus 4. We're going to take everything up to the x and then stop. The plus 1 and the minus 4, we are going to move our temporary points based on that. So what does the plus 1 in the exponent tell us is going to happen? The exponent, the number in the exponent moves it side to side, and that's backwards. So plus 1 is going to mean left 1. And the minus 4 will mean down 4. So our temporary points are going to be moved left 1 and down 4. Okay, so just taking y equals 3 times 2 to the x, we're going to plug in the x values -2, -1, 0, 1, and 2. If you have your own graphing calculator, if you want to put 3 times 2 to the x in the y equals and then fill out this table using the table feature, you can. If you want to borrow one of my calculators for that, you can. But I will show you on just normal calculators how to do this kind of quickly. So to plug in 3 times 2 raised to the -2, We do 3 times 2 raised to the negative 2. And we get 0.75. Okay. If you have to retype this every time, 3 times 2 raised to the negative 1, 3 times 2 raised to the 0, 3 times 2 raised to the 1, that's going to take a little bit of time, and the more times you retype this, the more chances you have to make a mistake. So, on a graphing calculator, you can push second enter, and it will re-enter the last thing that you typed in, and then you can go back and change the exponent to get the next part of your table. If you're using a scientific calculator, or honestly this one, you can just arrow up until you get to what you previously entered, and then go back and change the exponent to whatever it is you want it to be now. So let your calculator help you out. Don't retype it every time. Go back to what you entered previously and then punch it in. So again, on the graphing calculator, to do that, you do second enter, and it retypes what you had before. You can go back and change that exponent. So I've got 0.75, 1.536, and I believe the next one's 12. Now remember, these are my temporary points. So I'm going to use a tiny little x for each of these. So negative 2.75, there's a temporary point. Temporary. Each of those points need to be moved left 1 and down 4. So once you have the temporary points, move each point left 1 and down 4. It is helpful to have either different colors or different symbols so that you don't screw up what points are which. Now, when we moved this graph down 4, that also moved the asymptote down 4. So from the normal x-axis, I'm going to move down 4 and draw in a dashed line to remind me that, hey, my asymptote is now at y equals negative 4. When I draw in my graph, when I connect my points, I can't cross the asymptote. On a test or a quiz, if your graph crosses the asymptote, you will lose points because you cannot cross that asymptote. Also, try to make sure that your graph doesn't curve back up from the asymptote. You're not making a J. It needs to approach the asymptote, get closer and closer to the asymptote without curving away from it. Once we have this drawn, easiest part of today, what's the domain? All real numbers. The range has to do with the asymptote. So the range is going to be y something negative 4. To figure out that symbol, I want you to ask yourself, is the graph above the asymptote or below the asymptote? Anyone? It's above, so y is greater than. If it's above the asymptote, y is greater than the asymptote. If it's below the asymptote, y is less than the asymptote. For this example, we're going to take everything up to the x and then stop. So to get our temporary points, we are going to do y equals -2 times 1/2 raised to the x. And that's how you should type it into your graphing calculator. I believe on your assignment, the tables that I give you only have 4 lines instead of 5. It is okay to use -1, 0, 1, 2. That usually gives you enough information to see a good picture of the graph. Again, the trick in the calculator, type it in once, carefully, -2, parentheses, 1 divided by 2, close your parentheses, raised to the -1. And then to get the rest of your values, second enter, or on your scientific calculator, arrow up until you see what you entered before, and then change that exponent, and then continue. Oops. These are my temporary points. After the x, is there any horizontal movement in the exponent? Is there any number added or subtracted in the exponent? If you're watching the video, I'm sorry, my 4th hour is like dead to the world today. No, there's nothing added or subtracted in the exponent, so there's no side-to-side movement. What does the +1 indicate? Up 1. Which means the asymptote is also going to move up 1. So you might want to go ahead and put that information in there. So take each temporary point and move it up 1. And because you already drew in your asymptote, you can finish your graph, making sure it doesn't cross your asymptote. Domain. All real numbers. Range. Y is less than 1. Less than because the graph is below the asymptote. That -2, the negative flipped that graph over the x-axis before it moved up 1. That flips it underneath the asymptote, flipping that greater than to a less than.